Hello physics students, this is Mr. Downing again. This is some more practice with the word problems. You should have just watched the video that introduced this paper and this topic. So I have some more questions here. As I'm going through them, it's important to remember I'm using this how to solve a problem. This is nothing magical. It is simply a list of steps that follows logic. So the first thing I'm always doing is I'm writing down the numbers. So I'm rewriting any measurements listed in the problem. When writing your measurement, make sure you write both the number and the unit down. Write them out on the list. So I'm writing down the numbers and including the units. Once I've done that, I go to step 2. Step 2 is where I identify the numbers. Identify what type of measurement each one is and write it down so each measurement is labeled. Is it a distance, a force, a velocity, mass, momentum, or otherwise? Use the units and use keywords in the question to help you figure it out. The important part to remember about this is that it's multiple choice. Whatever you're identifying that number is one of the words off the formula chart. Once we know what numbers we have, we'll move down to step 3 and try to figure out what they want. We'll read the question again and write down what kind of measurement the answer will be. What does the question want us to tell them? Do they want acceleration, distance, a mass, or something else? Look for keywords, they'll help. Again, what they're looking for will be one of those words in the formula chart. Now, we do those steps before because by knowing what we have and what we want, that'll help us find a formula. So when we pick out a formula, we're using a formula chart, find a formula that has the measurement you're looking for in it. If that measurement is in more than one formula, look for the formula that uses the types of measurements you already know. In some rare cases, you may need to use 2 formulas. The ones we're working on today are all pretty straightforward. They do require manipulation. So look at a formula. It has to have whatever we found in step 3 inside of it, and then the rest of the formula needs to be stuff from step 2. Now, most of the time we'll have to do step 5. Sometimes we'll get lucky and we will not have to. So we'll need to rearrange the formula. Manipulate the formula and rearrange it so that the measurement you're looking for is by itself on one side of the equation. Use algebra and make sure what you do to one side of the equation you do to the other. So we want to get what we're looking for by itself, so we have that equals. So whatever came from step 3, we want to be that equals and then everything else. That way we can go straight to step 6 and just plug in the numbers. There shouldn't be any thinking in step 6. It should have already been done earlier. We can just look up at what we did in steps 1 and 2 to figure out what numbers to put where. We know where to put them in step 5. So how does that look? So you can see I did a sample problem. An object with the mass 14 kilograms pushes the force of 84 newtons. So whenever I write it down, I write down the numbers and the units. Whenever I identify, I just put what they're equal to, and I write out the word there. In step 3, when I figure out what I'm looking for, I write out what I'm looking for, and I say that's equals to the question. That's what the question is. Step 4, I write down my formula. In step 5, I said I want acceleration, so I want to get that a by itself. It's not by itself, so I go ahead and move that m away by dividing both sides by m and canceling and rewriting. Now I know what a equals. It equals f over m. Now I can substitute those numbers in, and I'm done. Those are my 6 steps. So let me do that real quick here. So, if a motor uses 6 joules of electrical energy and has a power of 2 watts, how much time did the motor run for? So I write down my numbers for step 1. 6 joules, 2 watts. I identify them. If a motor uses 6 joules of electrical energy, power of 2 watts, that's step 2. They're identified. Step 3, I want to know what the question is. How much time? Step 4, I see what I'm working with. I pull up my formula chart. I need to find something as electrical energy, power, and time. As I look down, I'm looking at all the formulas that have time in it, and there's a bunch of them actually. I'm looking for the one that has electrical energy and power and time. So I find it here. Electrical energy equals power multiplied by time. E equals PT. Okay, so I have E equals PT. In step 5, I'm going to manipulate that because I want time by itself, but it's not by itself, so you multiply it by P, so I do the opposite of multiplied by P. I divide by P. Cross out, E over P equals T. Step 6, I no longer have to think. What's my E? Electrical energy? 6. Divided by, what's my P? Power, 2. What's time? Now is where I could bring out a calculator if there was for more difficult numbers, but this is easy. 6 divided by 2 is 3. Now you probably do know this, the units for time, and that's seconds. 3 seconds is my time. Okay, let's do one more. Let's look at this number 6 here. What is the voltage of a battery that has a resistance of 2 ohms, There's a number. And a current of 1 amp. There's another one. So step 1, wrote them down already. Step 2, identify. What is the voltage? There's a resistance of 2 ohms. This is a resistance. And a current of 1 amp. This is a current. Okay, step 3, what are we looking for? What is the voltage? So the question is voltage. Now I want you to notice how nice and neat I'm lining these up. So I can see all my numbers all in a row. All my equal signs are kind of there in a line. And here's my measurements: resistance, current, voltage. That when I get to step 4, I'm looking at my formula chart. I can look for something that has voltage, but also the others. So if I'm scanning up and down, I see, oh, current equals voltage over resistance. I equals V over R. Now, don't let it confuse you that when we say current equals voltage over resistance, that we abbreviate current with an I. We can abbreviate it with whatever you want. Remember, it's just a symbol. C was already taken, I wasn't, so we used it. Now, I'm trying to get V by itself. I see that I'm going to do some manipulation in step 5. The first thing I notice is I have a fraction, and I hate fractions. So to get rid of the fraction, I'll multiply by whatever's on bottom. Whenever I multiply whatever's on the bottom, it leaves me a convenient spot where R is on bottom, R is on top. That cancels. So now I have Ri equals V. And there, my V is by itself. Now in step 6, I can just plug in these numbers. So what is my R? It is 2. Times my I, what's my I? Current, that is 1. V is my voltage, that's what I'm looking for. 2 times 1, this is simple. 2 volts is my V. I don't expect you to know that volts is the unit. I do expect you to be able to get to 2 by following these steps.